Hello, everyone. On behalf of the entire GeoEnrichment product team and all of my colleagues here at Esri, it is my great honor to welcome you to this Dev Summit presentation to introduce you to GeoEnrichment. My name is Tony Howser, and I am the GeoEnrichment product manager. Today, I am joined by some great colleagues, Daniel Stauning, our product engineer, Dmitry Kozlov, our developer, and Lucy Guerra, who is acting as our Q&A session moderator today. She leads the Data and Location Services product management team, which I belong to. She is also the subject matter expert on all things data related here at Esri. We have a very packed agenda today, and I'm going to start off with giving a good overview of GeoEnrichment, first by describing it as an incredibly important concept, followed by how Esri exposes it as a unique and valuable set of platform capabilities. You're going to learn about the unique spatial analytics behind GeoEnrichment. You're going to learn about the global data behind GeoEnrichment. But most importantly, you're going to learn the ways that you can consume it to support your work, whether you are a seasoned developer, systems integrator, researcher, or student. GeoEnrichment at Esri is an increasingly important concept and a unique set of platform capabilities. GeoEnrichment describes the action of enhancing existing data with additional location-based context. The additional context can drive better understanding, analysis, and decisions beyond what the original data alone may support. Esri's GeoEnrichment capability provides access to global data describing people, places, and businesses with flexible output options that you can consume in your apps and solutions, and the ability to analyze, and this is very key here, user-defined study areas and sites around the world through advanced spatial analytics. GeoEnrichment exists in Esri as both an Esri-hosted platform capability and through Esri's on-premises offerings. GeoEnrichment can be accessed by our users through multiple tools and capabilities built into Esri software and solutions, and by developers through discrete location services. Custom development with GeoEnrichment is currently supported through REST, JavaScript, and Python client APIs and SDKs. I'm going to flip this a little bit, and instead of talking about inputs or parameters, I'm going to first discuss the three primary capabilities of GeoEnrichment and the corresponding information products that can be returned by the GeoEnrichment service and be consumed, integrated, or incorporated in your custom apps, workflows, and solutions. The first of these capabilities is data enrichment. The corresponding information product from your perspective as developers are JSON lists of queried location-based attributes and values for areas submitted in a request. Of the three primary GeoEnrichment capabilities, this one is probably the most flexible and relevant to you as a developer, especially if you're consuming the response output in a visualization or analysis tool driven by data. You can see in some of the screen captures how Esri leverages the data enrichment capability in our own software and maps. This is about querying specific attributes to join to a map layer or append to a table for on-demand context about a site, area, or place described by mapped features or rows in a table. While I'm here, please note in the screen captures that I'm enriching sites and areas of many different shapes and sizes. I'll talk about this more a little later. The last thing I want to say here is that while there are a lot of examples on the screen showing enriched data in the context of a map, I want to make sure you understand that data enrichment can definitely work without a map as well. For example, when simply enriching a table of addresses or lat-long coordinates with additional columns of data. The second of these three primary capabilities is the dynamic generation of demographic reports. This is supported by GeoEnrichment's integrated reporting engine. And just like data enrichment before it, these reports and the information within them are all driven by the contextual data associated with the areas. And in this case, the predefined report types that were submitted to the service in a request. In this case, though, instead of a JSON list of attributes and values, the returned information products are in the form of pre-formatted PDF or Excel-based reports, which can be streamed or downloaded from the service. These reports can contain relevant attributes, data-driven charts, and even embedded maps, as you see on the screen there. And finally, to round off the list of the 3 primary capabilities, Esri also supports the generation of data-driven infographic reports. These are a very visual form of reporting that is analogous to online dashboards. They are very popular for their modern look and feel, and their interactivity thanks to the fact that they are built by a talented team of JavaScript developers and designers. Again, these infographic reports and their visual interactive elements are driven by the contextual data associated with the areas that were analyzed in the submitted request. Like with demographic reports, predefined infographic report types can be specified in the request. The output information product can, in this case, be streamed or downloaded as HTML files or high-resolution static PDF documents. In this next section, I'm going to briefly talk about the types of input analysis areas that you can submit to GeoEnrichment through a request to perform data enrichment, generate demographic reports, or create those data-driven infographics. GeoEnrichment can be used to query or analyze 4 types of polygon-based areas. Let's look at the first 2 starting from the left. You can submit 1 or more set of lat-long point coordinates or street addresses. If you do not specify any additional option, by default, those points will be automatically buffered by GeoEnrichment to produce a 1-mile ring around each submitted location, and those ring-based areas will be analyzed. You can also explicitly submit a ring radius value along with your point coordinates or addresses. Similarly, and if you look at the second picture from the left, you can specify a service area radius around your point coordinates or addresses. These service areas can be based on drive time, drive distance, walk time, walk distance, or other criteria from your input coordinates or addresses. GeoEnrichment will dynamically create these areas and use them as the areas to analyze for data enrichment, demographic reports, and infographics. And the GeoEnrichment service has the ability to query 1 or more features in global, postal, and administrative geography layers. You do not need to submit the boundary coordinates or geometry, since the layers already exist and are maintained within the GeoEnrichment database. The list of available geographies will obviously vary by country or territory and are updated just like the enrichment attribute. And finally, user-defined areas are just that. You simply submit the polygon coordinates of the areas you want to analyze. One of the key features of the GeoEnrichment service is the ability to analyze user-defined study areas and sites around the world. The latter is made possible with proprietary spatial analytics, including Esri's population-weighted apportionment methodology and global population modeling. The result is the ability to query data, receive reports, and generate infographics which contain reliable estimates for a variety of study areas and sites. Okay, I promised earlier to go over some of the differentiating characteristics of GeoEnrichment that make it a unique and high-value set of capabilities. I'm now going to talk about Esri's population-weighted apportionment. I mentioned this previously. This is based on a classic demographic analysis technique, which, when used properly, can provide more accurate estimates for querying demographically related information with maps. The best way to describe this demographic apportionment methodology is through an example with pictures. So let's say I sell console video games in Europe and I want to analyze a ring-based area around a potential store location. Let's say that I have a map separated into 4 areas, A, B, C, and D, as you can see on the screen. Maybe they represent different postal codes. Let's say that they contain total video game sales summarized by postal code area. and you can see the total amounts for each area in euros. Given this information, what is a reasonable estimate of the total video game sales for my analysis area there? In this first example, I'm simply retrieving the total spending amounts within the mapping units that are touching or intersecting my red ring-based analysis area. And there is the total spending in euros. This probably works fine if the analysis area has a similar shape and size as the mapping units that it touches, but in this case it doesn't. I want a better estimate. So in this case we simply totaled up each of the areas A, B, C, and D as is. In the second example, we are leveraging a geographic technique called areal interpolation. The percentage of area that the red ring-based area analysis area covers in each geographic unit is used to weight the estimate. But there is one major assumption being made in areal interpolation. That assumption is that the spending, and by extension the underlying population, is uniformly distributed over each of the 4 areas. This is not the case. If you look at the settlement depictions on the first image on the left, you can see that the red ring-based area analysis area captures a metro area in area B, while missing most of the population and homes in area D. Because of these variations in population distribution, the estimates provided by areal interpolation in the middle example are likely to be significantly off. Now with this final example, it's closer to what Esri has implemented behind the scenes with GeoEnrichment. What you see here are representations of Esri's block points in the US and Canada, or modeled world settlement points in most other parts of the world. Each point is associated with a population estimate for the micro area. Some of these areas contain no population at all. When the red ring-based area I submitted to GeoEnrichment, the service quickly summarizes the count of the captured population in each mapping unit and calculates the percentage of the captured population by area. This percentage is used to weight the values in each mapping unit, and the resulting value is returned by GeoEnrichment. You can see that the 542,600 euro value is vastly different from the previous 2 examples. What is amazing is that GeoEnrichment does this for all those input analysis area types that I showed previously, and for most of those attributes returned in data enrichment, demographic reports, and infographics, all in a few seconds or less. This can oversimplify the methodology somewhat, but I think it helps explain some of what's going on behind the scenes to provide our users and you, our developers, more accurate demographic estimates in GeoEnrichment's output information products. GeoEnrichment, through data enrichment, reporting, and the infographics capabilities that we just covered, summarize the predominant characteristics of people and their behaviors and businesses associated with analyzed places or geography. GeoEnrichment supports a bunch of data on people and their preferences and information about businesses. This includes Esri's demographics, which are a collection of demographic and spending data for over 130 countries. On average, there are about 100 variables for each country. And in countries like the US and Canada, there are upwards of 10,000 variables per country. These variables or attributes include population, household size, purchasing power, age, education, and more. They also include total and per capita spending on topics such as food, clothing, medical expenses, and more. Data are used for analyzing markets and consumers. for identifying underserved or vulnerable communities, and for formulating better business decisions and policy decisions as well. The data are available for many different levels of geography, including administrative and postal geographies, and are updated on an annual or biannual basis. In the U.S. specifically, Esri has a team of professional demographers, statisticians, and data scientists who model annual updates to demographic data. This includes socioeconomic, demographic, spending, segmentation data, daytime population data, market potential, and business data sets. In addition, U.S. Census and American Community Survey data are included. For American Community Survey, or ACS, Esri includes not only the estimate, but also the margin of error and a reliability flag to help users and developers understand and use the data effectively. Well, everyone, this concludes my portion of the presentation today. I'm going to now pass it along to Daniel, who will show you some of the ways that Esri is consuming the GeoEnrichment service today, followed by an overview of our new developer documentation and samples. Take it away, Daniel.
Thank you, Tony. What I want to do now is show what GeoEnrichment looks like in action. So we'll get started right away with some demos. First, we'll take a quick look at some of the applications that already exist that use GeoEnrichment. We'll show what some of those workflows look like. And then we'll do a quick rundown of the new developer experience and show how a developer can get started using GeoEnrichment with the ArcGIS platform. So let's get started here. Now, to get an idea of how GeoEnrichment is being commonly used today within some of the existing applications, let's take a quick look at ArcGIS Business Analyst, and we'll see how we can query and visualize Esri's demographic data. And there are Business Analyst web, desktop, and mobile applications, as well as a web app builder widget. So first, let's take a look at the web application here. Now, a common workflow here would be to search for a location. We'll search for the Esri campus, and this will drop a point on the map, and then we'll create an area around this point. So for example, we could create some rings around this point, 1, 3, 5 mile rings here. We can change this. For example, let's create some drive time service areas around this point. And now that we have our area defined, we'll want to get some information for this area. So let's open up an infographic. And here we can see some demographics for the area represented in this one-page report. These panels are interactive, and you can drill down into the panels to get some more information. And this can be exported to a PDF or dynamic HTML. And we'll create a PDF here. And this is a very common workflow. You have some point locations. You need to understand these areas better. And so with GeoEnrichment, we can add some context to these areas. We can define an area around the point, and we can get some information for it. Now, if we go back and look at each of the steps in this workflow, I just want to show that we use 3 different location services here. Now, when I search for a location in the search bar, this used the ArcGIS geocoding service to find the address and to drop a point on the map. And then when we created our drive times around the point, we used the routing services for the service area. And then we got some information for this area using GeoEnrichment. And so now the numbers that we see here in our report, this is the demographic data that's returned from GeoEnrichment. And now if we look at the web app builder widget, for example, we'll see kind of the same pattern here. We can drop a point and define an area and get some information for the area. So now let's do a quick rundown of what's available to you as a developer if you're learning the system for the first time, and how you can get started accessing these location services to build something like this. And that leads into the ArcGIS platform. This is a new platform as a service offering with a brand new developer guide and tools for building full-featured mapping applications and solutions. There are examples here that illustrate how to use ArcGIS, open source, and third-party APIs to build applications. So let's take a look at the GeoEnrichment topic. And here we'll see a breakdown of what GeoEnrichment is, how does it work, what are the key parameters, and how do you access the service. And if we look at the live examples, they progress from very simple, the minimum required to enrich an area, to a more medium level of complexity as we introduce examples that have more parameters. So the first example is the most simple use case. We can select one of these predefined areas, or we can click on the map to drop a point. And this will create a default 1 mile buffer ring around that point. And it will return a list of key facts about population totals for the area. This list of facts can be changed. There are over 15,000 data fields in GeoEnrichment that we refer to as analysis variables. These analysis variables are grouped thematically into categories. These categories are what we call data collections. So a data collection is essentially a predefined list of analysis variables. And in our next example, we introduce this concept of a data collection. We show how you can get a different list of facts. For example, the educational attainment for the area. In our next example, we introduced a study area options parameter. And this allows you to define the area. So instead of the default 1 mile ring buffer, we can create a drive time service area. And we can open the code pen. These are live examples that are visible in code, and this will take us to the page of sample code that shows you how it works. Now, the first thing to do here is to plug in our API key. And I'll talk more about this in a minute. But for now, if I just search for API key, we'll find where we need to put it, where it says your API key right here. I'll paste in my key, and the map will load. And now we can experiment with this sample. For example, I can change the 5-minute drive time to a 10-minute drive time. And we'll see the service area update on the map. And going back to the example, let's take a look at the code snippets here. And if we open up the code switcher, you can see examples for all the APIs that are supported. So not just Esri's JavaScript API and Python API, but also open source APIs from Esri, such as Esri Leaflet and ArcGIS REST.js, and even other providers like OpenLayers and Mapbox GLJS. And there are example requests for using curl to send requests directly to the REST API to call the enrich method, and examples of what the response looks like. Another tool that I'll show here is called the data browser. I mentioned earlier the concept of data collections and analysis variables. So just to recap, analysis variables are the data fields that we request from GeoEnrichment, and data collections are pre-assembled lists of these analysis variables grouped together in categories. So this tool allows us to explore these categories and see what variables are available. So if we open a category, we can hover over the information icon for one of these variables and get a description. And also provided here is a shopping cart-like experience where we can select the variables we're interested in and then export them to a JSON array. And then we can plug that array into the analysis variables parameter when we call the enrich method. What I'd like to do now is go back and talk about the API keys that I mentioned before. Now, these are an industry standard mechanism of authentication to the location services. You can create them in your dashboard on the developer.arcgis.com site and scope them to the services that you need. So to support all the workflows that we just demoed, our key will need to be scoped for the base maps, which is automatic when you create your key, the geocoding to search for places, the routing for GeoEnrichment to be able to discover the travel modes, the service area to be able to create those drive times, and then GeoEnrichment to enrich our area with demographics. And also provided with these keys are detailed usage metrics so that you can monitor the usage of your API keys. And that's a quick rundown of the new developer experience. It's as easy as signing up for an account, getting an API key, and getting started with the new developer guide and live samples. I'll also mention that there's a more detailed REST reference for GeoEnrichment that has more detail on some of the optional parameters. But we really recommend for a developer who's just learning the system for the first time and getting onboarded to start with the new guide for the ArcGIS platform. And lastly, just to bring this full circle from when we looked at Business Analyst in the beginning of the demo, we looked at Infographics. These are the interactive reports that help to visualize the data in a compelling way. This is a JavaScript component that will be available soon working alongside Esri's 4x JavaScript API. It's available now at the 3x API, and there are some examples that are available. And the team is working hard to get this working alongside the 4x API later this year. And when it's ready, we'll be adding a page to the new developer guide to provide examples on how to use it. And that wraps up my part of the presentation. So now we'll turn it over to Dmitry, who's going to show some more examples of how to use GeoEnrichment.
Thank you, Dan. Let's take a look how all of this works in the Coda samples. In the first sample, we will consider the task of massive population vaccination against COVID. Let's assume this vaccination will be done through CVS pharmacies, and we know that the first wave of this vaccination is focused on senior population. So let's find out which CVS pharmacies are best one for initial vaccine distribution. We will consider amount of senior population living within 5-minute drive time area around CVS pharmacy. I already did initial steps and created API key and allow usage through it geocoding, service area, and GeoEnrichment services. To build samples, we will use RGS API for Python. This library contains a set of useful classes to access the RGS platform functionality. In particular, it has RGS GeoEnrichment module, and the module allows you to get list of countries with data available for enrichment, and allows you to create report for certain study area and enrich it. That means to add specific demographic attributes to this area. Okay, let's import this library and use our API key to access RGS platform. Our input is Excel document with address, city, state, and zip of each CVS pharmacy in Los Angeles area. Let's edit this document and create address-based study area for each CVS pharmacy location with 5 minutes area around it. So area looks like this. Now we will choose necessary analysis variables in data browser. So variable is selected. Let's copy it as a JSON and paste it in notebook. Let's run enrichment. It takes some time because behind the scenes, GeoEnrichment server build drive times. Now it's finished. And what we can see here is that area type is drive time and size is 5 minutes. Aggregation method is block apportionment, and we use most detailed statistical layer, US block groups in the United States. Also, we can see that senior CI field is added to enrichment result. Let's map enrichment areas. We can see about 500 areas on the map, and blue color indicates most senior populated areas around U.S. pharmacies. Let's do next step. Let's sort this data frame by senior CI field and pick up 10 most populated one. So let's put everything on map and we can see several areas. Unfortunately, top of them are overlapped, so in practice, load will be separated between these CVS pharmacies. But the bottom one are best for initial vaccine distribution. And we can see that, for example, Huntington Beach area has 17,000 seniors living around it. In the second sample, we will analyze certain extent and we will find areas with prevalent senior population because such areas has a high risk of COVID impact. Let's import RGS API for Python library. This time we will use different way to authenticate on RGS platform with username and password. Let's create a map for Redlands area. Okay, map is created. Now let's use generate tessellation tool to build 1 square mile hexagon grid in the map area. The grid is created. Now for each 176 hexagons, let's create polygonal study area. Let's enrich all of these hexagons with two analysis variables, total population and number of seniors living in the area. We can see that these two variables are added to enrichment result. And now what we are going to do, we will create number of percent of senior population and we will select areas with more than 25 senior person populations. We have 9 areas. Let's map them onto the map and we can see that areas are located in South Redlands. Let's do one more step and show younger and senior population in the area for each hexagon. Let's find out most senior area and draw into the map. We can see that this area is located somewhere in Terracina Boulevard in Redlands. Let's dive into this area more deeper and build infographic report. We will create coronavirus impact planning report. If you open the report, we can see that it contains area, some at-risk population attributes, and health insurance information, and the other key indicators for the area. Also, create reports allow you to build report in HTML format. Let's build another report called Health Care and Insurance. If you open it, it contains interactive information, for example, age population distribution, and for example, number of people doing exercise with different frequency, and even more. You can compare it with state and county averages. Finally, all samples shown in presentation will be available in GitHub repository with all necessary data, so you will be able to reproduce all of this. And now I'm going to send it back to Tony with some follow-up resources.
Thank you, Dmitry. I just want to point out to everyone that the GeoEnrichment module in the ArcGIS API for Python is a wrapper around the GeoEnrichment service, with lots of great benefits such as the rich mapping and spatial analysis capabilities that you saw today. You absolutely have the option to consume the GeoEnrichment REST endpoints directly with your API keys, and Daniel gave you a great tour of that earlier. I'm now going to spend a couple of minutes summarizing what we went over while providing you with some useful links so you can find out more and quickly get started. Daniel showed you some examples on how Esri itself consumes GeoEnrichment in our applications and solutions like Business Analyst. He also walked through some of our new developer documentation, including showing you the very useful data browser and our API keys. Dmitry provided a walkthrough of some of his own custom code which consumes GeoEnrichment with our Python SDK and our REST API. He also shared those code examples with all of you through that rightmost link there on the screen. I also went over some information about our data. Esri makes a substantial investment in acquiring, processing, and integrating our global data. So we want to make sure that you have access to all kinds of information about it. I strongly encourage you to check these resources out. To summarize, GeoEnrichment is a very unique and powerful set of platform capabilities that allow you to query and obtain detailed and reliable information about people, places, and businesses for analysis areas around the world. GeoEnrichment leverages Esri's spatial analysis competencies and DNA to provide you and your users with reliable query estimates, primarily in three ways: as lists of enrichment attributes and values, as demographic reports, and as data-driven infographics. You, as developers, systems integrators, and data scientists can then consume and leverage these information products in an unimaginable variety of custom apps, tools, and solutions for visualization, analysis, and decision support. All right, it's now time for our Q&A session, and that means I hand it off to our Q&A moderator and resident data expert, Lucy Guerra.
Thanks so much, Tony. So thanks so much for joining all of us this morning. Please feel free to continue to ask questions in the chat window. If we're unable to answer your question, please reach out to us in a direct chat. But what I'd like to do right now is kick things off with some commonly asked questions about the GeoEnrichment service. So Tony, I'm going to kick this one to you. What are the primary developer authentication methods for working with GeoEnrichment?
Thank you for that question, Lucy. So there are two primary authentication methods for accessing GeoEnrichment in the ArcGIS platform, Esri's platform as a service offering. They are API keys. Those are permanent tokens that grant your application access to our ready-to-use services. And with an ArcGIS developer account, also private content. And the second method is to use OAuth 2.0 based application credentials. These are temporary tokens generated via OAuth 2.0 that can authorize access to ready-to-use services like GeoEnrichment. Thank you, Lucy.
Okay, great. And Dan, maybe I'll throw this one your way. What are the benefits for using API keys?
Well, the benefits for using API keys is that it's the industry standard for today, and you can scope the different location-based services to your key and embed those in your application so that your end users don't have to log in.
Okay, great. And Dmitry, what about Esri-hosted developer options for working with GeoEnrichment?
Thank you, Lucy. We have Esri hosted GeoEnrichment service that is part of our JS platform. So you can use it through API key, you can use it through subscription if you have one, and there is several libraries. So one of them I just showed, it's JS API for Python, and you can use it GeoEnrichment through it, but it not exposed all features. So for some options, REST API access will be preferred. Thank you, Lucia.
Sure.
And Lisa, can I add on to that?
Yeah, please.
So, so Dmitry just talked about the Esri-hosted options and capabilities through the platform. There are also some on-premises options. So, if there's like a systems integrator or an organization that wants to host and consume GeoEnrichment, GeoEnrichment actually has a lot of its roots in the business analyst family of products, and perhaps they want to host the GeoEnrichment service and access the content and the analytics with business analysts. Then there are options with business analyst products such as Business Analyst for ArcGIS Pro. It is a desktop software solution for market analytics. It includes GeoEnrichment-based geoprocessing tools and ArcGIS Pro-based Python modules, analogous to what Dmitry showed in the video, which can access both online and locally installed versions of the GeoEnrichment capability and supporting data. And then for you systems integrator types, there's Business Analyst Enterprise. It is a complete ArcGIS enterprise-based solution for hosting and supporting GeoEnrichment and Business Analyst family of products within your organization in your own infrastructure. Similar to the Esri-hosted set of platform capabilities that we went over, you'll be able to access GeoEnrichment-based capabilities in the REST, Python, and JavaScript client APIs and SDKs, but this time hosted by you on-premise or in your own infrastructure. Thank you.
Okay, thanks, Tony. Another question, does it take credits to use GeoEnrichment? We talked a little bit about this in the session, but can you drill into that a bit more?
Okay, I could take this. I did reply with this in the chat, but there's actually, with the ArcGIS platform, the cost is based on your actual consumption or usage, and you are billed monthly in US dollars. It's a pay-as-you-go model with no subscription required. And as I typed in the chat, you can go to developers.arcgis.com, and from there, click on the pricing tab to get more information there. And then we have the ArcGIS online subscription model. This is a service credits-based business model, and it's useful for ArcGIS developers who want to work with, in the context of an ArcGIS online organization, and the elements associated with it, such as groups and items. So you could go to arcgis.com to get more details on ArcGIS Online and the pricing there.
Perfect. And that kind of leads us into another topic, and this is about where we can help users find additional information. And so you talked about business analyst prior to this. Where can users get more information about business analysts specifically?
That's a great question. You saw many examples of business analysts in the presentation. I would describe it, again, as a first-class client to the GeoEnrichment service, Esri's client. You know, this is the Dev Summit. It's a great example of how to consume and leverage the content and analytics behind a GeoEnrichment. You can get more information about business analysts by going to the ArcGIS Business Analyst channel in the Ask Our Experts tab in the conference site, and by visiting business analyst product pages at esri.com/BA. Again, esri.com/BA.
Great. Great. And another thing I wanted to add is for our audience today, Don't forget that you can download the slides that were presented, and a lot of the information is contained within them as well. Okay, let's see. If you have specific questions about the GeoEnrichment service, there's also a channel within Ask Our Experts for the GeoEnrichment service specifically. You can go to ArcGIS platform channel for additional information there. Okay, so one of the questions that came in was, is there a 1 or 2 sentence summary of how GeoEnrichment works that I can share with customers? And we did post a reply in the window, but I thought it might be good for us just to do a high level what GeoEnrichment is to help help these users promote this elsewhere within their organizations.
Okay, and that's a very good question. To explain it at a very high level, I usually start with the one-liner. It's the action of enhancing existing data with additional location-based context. And that's like C-level description. So why is this important? Well, that additional context can drive better understanding, analysis, and decisions beyond what your original data alone may support. So this has all kinds of implications because it can support statistical modeling, machine learning, AI, a lot of the topics you're hearing in the conference, and other data science applications where this geodemographic context can be leveraged as or augment your observations, can be used as training data, can be used as validation data.